Hello everyone, this is Ashutosh Tiwari. Today in this lecture I will teach you about motion in a straight line. What is motion? Motion is the change in position of an object with time. Motion is everywhere in our day-to-day life. We walk, we run, cycle and drive. At the same time, leaves fall from trees, rivers flow, and then earth rotates on its axis. So, all these are the examples of a motion. Motion in a straight line is called rectilinear motion. In our day-to-day life, for the sake of simplicity, we treat objects as point objects when their size is very small compared to the distance they move. The example is a car moving on a highway. When a car moves on a highway, we treat it as a point object, even though we know it is not a point object, but we treat it as a point object because its size is much smaller compared to the distance on the highway over which it travels. So, these are the terms which you should be familiar with. Now, I would like to introduce another term which is very widely used, and that is called kinematics. Kinematics is the branch of physics that describes how objects move without explaining why they move. So, the key points of kinematics are that it focuses on motion itself and not on the forces which cause this motion. So, in this subject kinematics, we study position of the objects, velocity of the object and acceleration, that is how quickly they are changing their speed. So, in this lecture we will focus on rectilinear motion and learn the concepts of average velocity, instantaneous velocity, speed, acceleration and the equations for uniform motion. What is velocity? Velocity is the change of position of an object with time. It tells us how fast an object is moving and also it tells us in which direction it is moving. So, velocity is a vector quantity. It has both magnitude and direction. Suppose a car is moving in the east direction with a speed of 30 km per hour. So, we say it has a velocity of plus 30 km per hour. On the other hand, if it starts moving in the west direction, we will say it has a velocity of minus 30 km per hour. Now, coming to average velocity. Average velocity gives the overall change in position over a finite time interval. For example, suppose an object travels delta x distance over a total time of delta t, then we will say its average velocity is delta x by delta t. It tells us how fast an object is moving on average. For example, suppose a car is traveling and in 2 hours it covers a distance of 120 kilometers and in a straight road, then this average velocity will be 120 divided by 2, which is 60 km per hour. So, in the last example, we saw a car moving for 2 hours over an 120 km distance had a velocity of 60 km per hour, but that does not mean that the car always moved with that velocity all the time. Sometimes it might have gone with higher velocity and sometimes with lower. So, now comes a term instantaneous velocity, and it tells us the velocity at a specific instant of time. So, here the instantaneous velocity will be given as delta x by delta t, but delta t should be very small, it should be approaching to 0. So, it is basically the speedometer reading at an exact moment. In the graph which you are seeing here, I have plotted on y axis the distance travelled by an object and on the x axis the time which it is going over. So, instantaneous velocity is the slope of the tangent on the position x t graph. So, let me elaborate this little bit more. Here what you are seeing, this is plot is going from here to here, is position on a y axis and time on x axis. Now, if I have to find the average velocity of this object, what I can see is that it traveled, started from x equal to 0, which is here, and went to x equal to 100 distance over here. So, it traveled 100 centimeter and in the time of 10 seconds. So, its average velocity will be 100 by 10 equal to 10 centimeter per second. But this was not the same velocity at all instants of time. For example, at t equal to 0, this object was at rest. So, its velocity was almost 0, and then its velocity increased slowly and then it finally reached to this point. So, if you have to find the instantaneous velocity, then what you should do is that at that moment of time where you want to find the velocity, you should make a tangent to this distance versus time graph, and the slope of that tangent will tell you how much is the instantaneous velocity. Now, coming to speed. Speed is the magnitude of velocity. It ignores the direction and it is always positive. For example, if the velocity is 20 meter per second or minus 20 meter per second, the speed will always be 20 meter per second. Now, let us look into the acceleration. Acceleration is the rate of change of velocity with respect to time. It tells us how quickly an object speeds up or slows down. It is again a vector quantity and it has a unit of meter per second square. The formula for acceleration is a equal to delta v by delta t, where delta t is the time interval over which the velocity changed by delta v. And if you want to find instantaneous value, because acceleration also can be different at different period of time, then you should calculate delta v by delta t in the limits of time delta t tending to 0. So, this again basically will be a slope of v versus t graph, which we will study in later slides here. Now, coming to types of accelerations. Acceleration can be positive, where the velocity increases with time, is example a car is speeding up. It can be negative, deceleration or retardation is a word for that, and here the velocity decreases with time, example is a car slowing down when brakes are applied, and also it is possible that 0 acceleration. So, velocity remains constant, example is a car moving at a constant speed. Graphs of motion are very important, which you should learn by heart. These graphs provide a visual understanding of how an object moves. There are three kinds of graphs that we will go through. The first one is a position time graph, xt graph, second is velocity time graph, and the third one is acceleration time graph, at graph. Here I have shown some representative position time graphs, xt graphs. On the top left is a graph with flat line. The position versus time is position is not changing with time. So, it means object is at rest. The second graph is a straight line. The position is changing in a linear fashion with time, and this represents a constant velocity. Then on the bottom left, we have a graph where there is a curve, upward curve. So, position versus time is showing upward curve. It is an example of positive acceleration. So, as the object is moving with time, it is accelerating, its velocity is increasing. And then the last example on the right hand side, on the lower side, is the downward curve. So, it represents a negative acceleration. And in our day to day life, we all the time observe these kind of patterns in motion. In this graph, I have shown the velocity versus time graph. Again, the left one on the top is a flat line which shows the constant velocity. So, as you are seeing, even when the time is passing, velocity remains the same. The second graph on the right is velocity versus time, which is showing a straight line with positive slope. It means the velocity is increasing with time and acceleration is positive. And then on the left bottom, I have shown a straight line with negative slope. So, here the velocity is decreasing with time and it is an example of a negative acceleration. And then the fourth graph on the right hand side of the bottom is velocity versus time, and what I have shown is the area under the curve. The area under the curve here, which you are seeing, this whole area. So, this represents the distance travelled by the object. So, if you integrate this area, you will find how much distance this object has travelled with time. Here comes the acceleration time graph. Again, the left one on the top is a flat line which shows the constant acceleration. So, it means the object is continuously increasing up, speeding up. Then on the right hand side is a flat line below the x axis. So, it is a negative acceleration throughout, and this what it represents is that car is continuously slowing down. On the bottom left, I have shown the area under the AT graph, and that area represents how much is the change in the velocity over a given period of time. So, the summary of the graphs which we studied, the graph type x versus t. If you find the slope of this graph, you find the velocity. Then if you plot the v versus t, here the slope represents the acceleration and the area represents displacement. And then coming to a t graph, here the area represents the change in the velocity of the object. Kinematic equations of motions. These equations relate displacement, velocity, acceleration and time for an object moving in a straight line with constant acceleration. So, these are very important equations. There are three equations. The first equation of a motion is v equal to v naught plus at, where v is the velocity, final velocity, v naught is the initial velocity, a is the acceleration and t is the time. Second equation of motion is x equal to v naught t plus half a t square, while the third equation of motion is v square equal to v naught square plus 2 a x. Now, I will give you some very important tips when to use which equation. Suppose in a question you know the time involved, then you should use v equal to v naught plus a t or x equal to v naught t plus half a t square equation. On the other hand, if in this problem time is not given, only you know the initial and final velocity and distance, then you should use v square is equal to v naught square plus 2 a x. Now, we will go through some questions, so your concept becomes clear. Question number 1 is a ball is thrown vertically upward with a velocity of v naught 20 meter per second square, and you have to find the maximum height it reaches and time taken to reach back to the thrower. and it is given that g, which is the acceleration due to gravity, is 10 meter per second square, and they have mentioned it is acting downwards. So, when you solve it, you have to take this into account, because g is 10 meter per second square, but acting downward. So, you have to take it as minus 10. So, let us look into how to solve. For upward motion, we know that at maximum height, when ball will reach, its velocity will become 0. So, v should be taken as 0. Now, you use the equation v square equal to v naught square plus 2 ax. Putting v equal to 0 and v naught equal to 20 and value of g as minus 10 in this equation gives us h equal to 400 by 20, which is 20 meters. So, ball will go till the height of 20 meters, and then it will start coming down. So, second part of this question is find the time taken to reach back to thrower. So, when you throw the ball up, it will go up, it will take some time, and then when it starts coming back, it will take equal time. So, to find the total time, let us first find the time ball takes to reach to the highest point. For that, you should use the equation v equal to v naught plus at. Final velocity v will be 0 and v naught is given as 20. So, if you put it along with the fact that g equal to minus 10, you come up to the time as 2 seconds. So, this is the time ball takes to reach to the maximum height, and then from maximum height to the ground it will take the same time. So, you have to just multiply by 2. So, total time taken will be 4 seconds. Now, let us look into another question, question number 2. An object is dropped from a height of 45 meter. It asks to find the time to hit the ground and then find velocity just before hitting the ground. To solve this equation, you should use the formula x equal to v naught t plus half at square. Because ball is dropped from the height, it is moving downward. So, you should take h as minus 45 meter, because direction is very important, and we know that displacement is a vector quantity. Now, if you put this minus 45 in that equation, we get minus 45 equal to 0, because initial velocity was 0, minus half times 10 into t square. If you solve it, you get t equal to 3 seconds. Now, for the second part of this question, that is finding the final velocity, you should use the equation v equal to v naught plus at, and with v naught as 0, time 3 seconds and g minus 10, you come up with a velocity of minus 30 meters per second, and negative sign here indicates downward motion. So, ball will go in downward direction. Now, look into the question number 3. A car is moving at v naught equal to 72 kilometer per hour, which is also same as 20 meter per second, and it is stopped by applying the brakes with a equal to minus 5 meter per second square. Find the stopping distance. To solve this question, you should use the equation v square equal to v naught square plus 2ax, and v is 0 because it is coming to rest, v naught is 20 and acceleration is minus 5. So, if you put all these numbers, you come up with a value of d as 40 meters. So, it will take stopping distance will be 40 meters. Okay, so here are some key points to remember. Displacement is the change in position. Velocity is the rate of change of position. Acceleration is the rate of change of velocity, and speed is the magnitude of velocity and is always positive. Now, coming to the graphs, slope of xt graph gives us velocity, slope of vt graph gives us acceleration, area under the vt graph is displacement, and area under the at graph is change in velocity. Here are some important observations. Average speed is always greater than or equal to the magnitude of average velocity. Instantaneous speed is equal to the magnitude of instantaneous velocity. If acceleration is positive, it means speeding up. If it is negative, it means slowing down, and if it is 0, means uniform motion.